So what we're looking at today for the new stuff is we're looking at independent events, all right? So we know that two events, A and B, are independent if the occurrence of one event does not, emphasis on the not, change the probability that the other event will happen, okay? And then in other words, this is not other words, this is the event A and B are independent. It should be if and only if, but we'll just say if. Probability of A and, the probability of A given B is equal to probability of A, and the probability of B given A is equal to probability of B. Okay, so I'll give you a second to write that down, and then I'll try and explain it a little bit better. Okay, so basically what we know is this, is that the stuff in A is not going to help us to predict stuff in B. Okay, so that's what we're saying, is that when our two events are independent, knowing that one event occurred won't help predict the other event occurring. Okay, so basically what we're saying is that if I know that B's happened, it's not going to help me predict A. Okay, so that way we know that they're independent. We're going to give you an example of what we're actually looking at. Okay, we actually got about 3 examples. Yeah, 3 examples. Okay, and I'll probably get through one today with the where we're at with the time in class, but that's all right. Okay, so we're going to try to explain this a little bit easier. Okay, we're not doing chi-square yet. All right, so this is the question. You're doing a finger length. We're working through, I'll let you read through the question, but basically they took 452 students, female and males, and they're looking at the left hand. We're looking at whether or not their index finger is longer, their ring finger is longer, or that they have the same length, okay? So what we're looking for is we're not testing anything, we're just testing for independence. We're not doing chi-square, goodness of fit, until third try. So to do independence, what we're going to need to know is we need to have our test. We have probability of A, and we need to know the probability of A given B, and then we need to do the probability of B and the probability of B given A, right? Now, what I did is I said the event A is my female students, okay? And then my B is going to be my index finger, their index fingers, okay? And obviously you need to sit there and state what event is what so that you can perform the test, okay? And if you wanted to switch it up, that's fine. It's just you got to state what you've done, okay? So going back to the chart, I have 452 total students, and the probability of them being a female was 212. Okay, I'll come back and do all the math in just a second. Okay, now going back to B, B has a longer ring index finger. So if I come to index finger, I see that I have 123. So then I'm going to come to here and say this is 123, and then I have to go back to the female, which was 78. Okay, so I'm going to go to 78, and then I got to do it for the same thing for B. All right, so I have 452, and index is 123. And then the probability of A was females, so I go down to 212, and I go back up to the index finger. Okay, so what I need to do is do my calculator real quick. So let's see here. I got 4690. 78 divided by 123. I got 0.6341. 0.2721. And that's that. Okay, so when I say for independence, I need to know, does my probability of A given B equal the probability of A? So does these two equal each other? Are these two numbers the same? No, so therefore they are not independent. Okay, so event A and B are not independent. Sorry, let me scoot that over for you. All right. So basically what this means is so knowing that they have a longer index finger, I'll say makes it less likely that individual is a female. And then you could say the same thing with whichever way you want to do it. If you did this one, so knowing that a student is female makes it less likely that the individual has a longer index finger. Knowing that a student has a longer index finger, so knowing that they have this, that the individual is a female, well, you're looking at, I would still say less, that the individual is female. Oh, I see what you're saying. You're comparing these two right here. I guess you could say it that way too. But it's just, you're not going to, it doesn't, basically you just got to say that they're not independent. You're not going to tie them together. So that's what you got to look at. And independence is hard to prove. I'll tell you that much right now. Okay. But what we do is we'll say something like, if we're doing replacements with cards, so when we replace the card, each draw is going to be independent because we do replacement. If I don't do replacement, then they're not going to be independent because once I draw one, it's going to change the outcome of the other ones. Okay, and so from here on out, where we're going to start doing some tests and some real probabilities and stuff, is we have to sit there and say, we have to clarify, is it independent? Well, yes, because this event's not going to tie into the next event. Okay, and so it's hard to prove, but it's more of a common sense type of a thing. But it's important that we understand where it's coming from. Okay, good, nice and hazy. That's good. Okay. Um, so I forgot. I meant to put that like that. They don't equal each other. So what we're going to do is on Friday, it's going to be a work day. I'm not going to give you the second assignment for this one yet. Um, you can work on it later, but the other stuff is out there. So there's 2 assignments from 5.1, there's 2 assignments from 5.2, and then there will be 2 from 3. I've only given you the first one, okay? So if you're all caught up, then you have an easy weekend. No, I'm not